In this video, I'm going to talk about what we would term simple experiments. Really, anytime you're talking about an experiment, it's a slightly more in-depth or difficult design approach than a correlation. When we say simple experiments, it really more so has to do with the number of IVs that are going to be under consideration. The real distinction between correlational research and experimental research is this process of moving beyond the measurement of a variable to the manipulation of a variable. So in your 293 projects, when you just had a self-report scale where people told you how much self-esteem they had, how happy they were, how much they used social media, you're just measuring the extent of that variable. The manipulation of a variable is when you, the researcher, carefully try to change something about the variable to see how it can impact a second variable. So this is the process of what we call manipulation. So the whole time when we were all designing your experiments this semester, and we went through that process of creating two conditions where some participants would, let's say, think about a memory when they felt good about themselves versus a neutral control memory. This is at its most basic the process of manipulation. The idea that you're trying to cause an effect in your participants by changing something about what they're experiencing. So if you have only half of your participants think about the memory when they had a high sense of self-esteem, the idea is that you're trying to cause them to experience a heightened state of self-esteem. Manipulation is the process whereby we can explore causality, because if we're just measuring the extent to which two variables occur, you can only look into correlation or covariance. But by carefully changing something about the environment, changing something about our proposed independent variable, we try and see whether or not something happens down the line with our dependent variable. So the nomenclature here, your independent variable, this is always the variable that is being manipulated, your IV. The idea is that the independent variable is independent of what comes next. You predict that your independent variable can change the dependent variable, but your dependent variable can't do anything to your independent variable, so named the independent variable. The dependent variable, which is the name that I think is a little bit more intuitive, is the variable that you think will be affected by whatever you did with the independent variable. So the IV is the variable you're manipulating, the DV is the variable you're hoping to see changes in, or the outcome. The IV necessarily needs to come first, and the DV necessarily needs to come second. If you're hypothesizing that the IV can cause changes to the DV, logically the IV needs to occur first in time. It would be impossible to measure the DV and then manipulate the IV, because it would be impossible for something that happens after the fact to affect something that happened earlier in time. We're not living that particular episode of Doctor Who at this moment. The reasons experiments are able to help you establish the criteria for these more stringent causal claims is for three reasons. One is this notion of temporal precedence that I just touched on. The idea is the researcher will be in control of the course of time that participants are experiencing the different variables. The researcher can ensure that the IV comes first and that the DV comes second, so that you know that it couldn't be the DV causing changes to the IV. Whereas with the correlation, it really doesn't matter because you're just measuring the variables. It doesn't matter really the order in which you measure your variables. The temporal precedence in an experiment is very, very important. If you're predicting the IV causes changes to the DV, this necessarily needs to be part of how you establish the temporal precedence. For something to cause changes in something else, it needs to occur first in time. Now, one of the criteria for an experimental causal claim to be met is actually the same, overlaps with a correlational study. Essentially, you need to find that changes in the IV are associated with changes in the DV. So you're in control of the changes happening with the IV. You're creating the conditions, but there should be an ensuing change in the DV. Basically, if you create your different conditions that represent your manipulation and you don't see that your experimental group and your control group differ in levels of the DV, well, you don't have that covariance, so you might have made the most best intentioned experiment of all time, but if there's no effect on your DV, there's no criteria for a causal claim. Then additionally, you have to be really careful about what we call internal validity. So this is really at the heart of creating good quality experiments. This is creating your experiments thoughtfully such that you're really making sure your IV is having the effect that you want it to. You're trying to rule out any alternative explanations whereby once you complete your experiment, you know for a fact that your IV caused a change to the DV. Now, there's all sorts of ways where this can fail to occur in a poorly designed experiment. So in this lecture and in the next one, experimental validity, we're going to talk about good experimental design, and we're also going to talk about bad experimental design. So we're going to start with our more simple experiments. So a simple experiment could also be termed a one-way design. A one-way experimental design is where only a single variable is manipulated, meaning there's only one independent variable. Again, this process of manipulation is the researcher actively changing something about the environment, namely the IV, to try and elicit an effect, or to try to see some change in the DV. So I'm going to go through a few hypothetical examples in this lecture. Let's start by saying we want to manipulate temperature to see how it affects aggression. If you've ever taken an intro to psych class or a social psych class, you might be familiar with research on temperature and aggression. A really consistent finding from this research is that more violent crime actually happens in the summertime. That's correlational, right? Temperature naturally rises in the summer and you can merely measure it. And you can merely measure rates of violent crime. You can't manipulate either one of those things. You're just assessing the covariance of those two variables. Now, certainly, one explanation for there being more violent crime in the summer is that temperature causes you to be more aggressive. Well, there's a lot of other alternative explanations that the correlational research doesn't rule out. Maybe the summertime is more so associated with more people being out and about, maybe in pre-COVID times, or maybe even in COVID times, you don't know, people are acting crazy. Maybe more people are out and about in the summer, so there's just more people on the streets, so there's more opportunities for crime and aggression. Maybe people drink more in the summer, and we know alcohol can definitely have an effect on aggression. So you can't really necessarily state with confidence, based on this very consistent finding of temperature and violent crime, you can't use that to establish that temperature causes aggression. You really need to go to the next step and design an experiment to manipulate temperature to try and elicit an effect. So you need to start by designing your conditions for your independent variable. So your IV is a single variable, but you need to break it into at least two sub-conditions or levels. So your independent variable in this context is temperature, but you need to break it into your experimental condition and your control condition. So let's say I decide to have one experimental condition where I raise the temperature in the laboratory by 10 degrees above room temperature. You necessarily need to have an equivalent control condition. This is meant to be a baseline that you can compare your experimental group to. So I would need to have half my participants be sitting in a normally heated room and additionally assess their levels of aggression. The idea being, if I just put every one of my participants in a hot room and measured their levels of aggression, how can I say that heat causes aggression? Compared to what? Maybe heat had nothing to do with it, but people are just naturally very aggressive. You need to have a control condition so that you can actually have a baseline to compare your experimental condition to. Otherwise, you really have no justification in saying that your IV causes changes to your DV. So once you've got your conditions for your IV, you would want to take measurements for your DV. So I would need to take aggression scores in my participants who were in the normal temperature room and the hot room, and I would have those two mean scores and I would compare to see whether or not those two averages were different. And that would tell me whether or not temperature, sorry, there's a garage door opening happening. The difference between those two mean scores would be what tells me that temperature seemed to cause a change to scores in aggression. So if you were to plot out some ideal data that shows an effect, you might see something that looks like this. So the two bars would represent the two mean aggression scores, the red bar indicating the heated room group, the gray bar indicating the control, normally heated group. You can eyeball those means and say those two means are different, but as you guys know from 293, you run statistical tests to really evaluate with confidence whether or not those differences are significant or meaningful. In this case, since we're living in the realm of simple experiments, you could just run a basic t-test, a t-test that compares mean differences between two groups. So if you're in a very, very simple one-way experiment that just has two levels to the IV, a t-test will be able to tell you whether or not there's an effect of the IV on the DV. Another example from social psychology research, a major question from social psych is whether or not isolation or ostracism has negative psychological consequences. And now there's a vast literature indicating just how important social belongingness is, and that isolation and ostracism does really hurt us in a variety of ways. So let's say a belongingness researcher was interested in whether or not social isolation increased anxiety. A really famous experimental paradigm that these researchers have developed is what's called the cyberball study. Some of you maybe have even been a participant in one of these studies, because I do know that they sometimes occur in various labs at Miami. The basic paradigm of the cyberball study is that participants are told they'll be playing a virtual ball toss game. They're told that there's two other players in other rooms at separate computers, and you're literally just going to have your computer avatars toss the ball around with each other. The control condition has you, the participant, getting the ball tossed to you a roughly equivalent amount of times that the other quote unquote participants seem to be throwing it to each other. Now, in reality, there are no two other actual participants playing this game. It's just a computer generated program. So the control condition, they're led to believe that they're being included normally by two other people, not knowing that it's just the condition that they were assigned to. The exclusion group, on the other hand, are told the same story, that they're going to be playing a virtual ball toss game with two other participants. After a few tosses, the participant starts to be excluded completely from getting the ball. They maybe get the ball a couple times, and then for the rest of the experiment, the other two avatars are just throwing the ball to one another. So participants are led to believe that this is just a ball toss game, but the key manipulation here is whether or not the participants were excluded or included normally. So you see our two conditions are exclusion versus normal inclusion. The ball toss game is just a cover story to make participants sort of not know the real purpose of the survey. But this is meant to prime a feeling of exclusion or ostracism, because then we can compare mean levels of anxiety by measuring anxiety after participants have completed the ball toss task. Then, if participants in the exclusion condition have higher levels of anxiety, then we can conclude that something about being isolated tends to lead to an increase in anxiety. So there's still some subtypes of one-way designs. There's still some further distinctions between the two types. One is going to mirror your independent samples t-test, and it's going to be a between subjects design. This is going to be when your participants are either in one condition or the other, right? Your participants are either in the inclusion or the exclusion. They don't see both conditions. They're either in the hot room or the normally heated room. The way you decide which participants are in which condition should be done via the process of random assignment. Essentially, you need to make sure that every single participant that walks into your lab has a completely equal chance of being in one condition or the other. If you use some non-random criteria to assign participants to conditions, it's going to diminish the internal validity of your experiment. Let's say, for example, you think it would be easier, let's say in your temperature and aggression study, to just put all the men in the hot room condition and all the women in the normally heated room condition. You then find that those in the heated room condition were more aggressive, and you claim, look, temperature increases aggression. Someone with an eye towards both internal validity and gender differences would say, well, wait, there might be gender differences in aggression at baseline. Temperature might not have had anything to do with it. People didn't have a completely random chance of being in the two conditions. So something like that, separating subjects by gender to be in different conditions, obviously that's a very kind of dumb example. That's definitely a no-go. Random assignment means every single participant who walks into your experiment has a completely equal chance of being in one condition or the other. This is going to be a really important component of creating what we call equivalence between the conditions. So if you're separating out your participants into conditions on any other non-random criteria, you always would have that doubt in the back of your mind that any effects of your IV were actually just due to the way subjects were assigned into conditions. Something as simple as having different school years, like all the freshmen are in one condition versus all the sophomores are in another condition. That is a non-random criteria, and all of that is a no-go because you would always have the lingering doubt that any effects of the IV were due to this other non-random characteristic. Okay, so all of this is to say the assignment must be truly random because any non-random way of assigning participants based on demographic characteristics, based on geographic location, based on time when participants take the survey, right? All of that could negatively impact the results. Here's another example that researchers often have to keep in mind. Let's say I decide to recruit all of my, let's say, experimental participants, B participants from an undergraduate subject pool who signed up earlier in the semester. Then my second condition was all students who signed up during finals week. Maybe my DV was something like conscientiousness or something like that. If I was to take participants who only signed up at the beginning of the semester and compare them only to students who signed up at the end of the semester, and I find that there's differences in conscientiousness, that could be due to the fact that I was recruiting these participants at different time frames. There's typically a difference between the undergraduate participants who sign up in the beginning of the semester to get all their credits out of the way versus participants who sign up at the very last week at the last minute. They're typically rushing through multiple studies, they're typically not paying as much attention. So even something like when you recruit someone can be seen as a non-random assignment criteria. So you always have to be really careful. Now, a way that you can bypass random assignment is going to be your within subjects design. There's going to be benefits to within subjects, downsides as well. Same thing with between subjects. It all comes down to what really works best for you. So within subjects bypasses this notion of random assignment because all participants are going to receive every level of your IV. So the equivalence is meant to be created by the fact that each participant is going to give you multiple measurements. So if you remember your repeated measures t-test, that would be based on a within subjects design. So if you're taking participants in the temperature and aggression study, you're putting them into the normally heated room, you're measuring their aggression, you move them into a hot room, and then you remeasure the aggression. Basically, you're going to be comparing every participant's score to themselves. You're going to see whether or not every individual participant's aggression score was higher at time 2. Now, this design does have, like I said, its benefits and its downsides. One would be if you have concerns about participants becoming suspicious. In a lot of social psych studies, it would be reasonable for participants to particularly be kind of suspicious and start to think about what's going on. Take that temperature and aggression survey. Wouldn't you find it very strange if you were in the middle of an experiment moved into a super hot room? It's just the kind of thing that participants are going to notice and they're going to be sort of weirded out. They might start to speculate in the purpose of the survey, and that can affect your results. So you need to be careful with the within subjects design that it's not the kind of thing that participants seeing those multiple conditions is going to affect their responses. So there's strengths and weaknesses to both within subjects and between subjects. With within subjects, you do have to recruit less people because you're going to have all the same group of people in both of your conditions. Whereas in between subjects, you need to recruit a separate sample for your experimental and your control group. Additionally, there's no need to worry about random individual differences happening systematically, right? Technically, in your temperature and aggression study, even if you had met the criteria for internal validity, you're sort of always left wondering if for some reason randomly more aggressive people for no reason besides coincidence happened to be in your hot room condition. Obviously, that's not super likely, but it's always theoretically possible. Within subjects, you don't need to worry about it. You're comparing everyone's score to their own unique baseline. So you don't have to worry about these sort of systemic, fluky individual differences. A downside is that given that all of your participants are going through all conditions, they're going through more survey materials. They're just doing more stuff. They're answering more questions, doing more tasks. So they can get tired. If you guys have ever participated in a study, you probably know that it can get boring really, really quick. So if you're sort of doing repetitive tasks over and over, people can get fatigued, they can start to get tired, their performance can start to decrease, they pay less attention, and they're just over it, which is not an ideal circumstance for a participant. Now, between subjects, right, the pro is sort of the flip side of the cons for the within subject. So since your participants don't have to repeat a bunch of similar procedures, there's going to be less fatigue and also less cause for suspicion. They're not able to see that they were sort of in these multiple similar conditions to help them speculate as to what the purpose of the survey is. So particularly if you're using maybe some sort of subtle social psych type manipulations, between subjects is typically going to be for you. Sometimes participants can't be in multiple conditions, it just doesn't work that way. If, let's say, you want to evaluate the efficacy of a new treatment, you typically want to have people in a treatment group and people in a control non-treatment group. To have someone move from non-treatment to treatment, that kind of doesn't work. The problem you might run into is, let's say participants are in the non-treatment group and then after that in the treatment group, and you notice that the treatment group tended to be better than baseline. This is going to likely partly be explained by what we call sort of the natural progression of illness, or the idea that people sort of naturally get better. For the most part, when people are being treated for a disease, sort of no matter what, people can just get better naturally, regardless of their treatment plan. So if you have the treatment group second in the time course of the survey and people naturally are getting better later in time, you can't rule out that they just naturally got better because more time had elapsed. So then the downside, you need more participants and you need to be careful about random assignments. So there's obviously ups and downs to both of these designs. It just depends. I know for the most part, a lot of social psych research is going to use your between subjects. I know a lot of cognitive research and a lot of neuroscience research where there's no worry about suspicion. Within subjects, design is going to work just fine. So it depends on your goals. So that's going to be it for the lecture on simple experiments. I'm going to pick back up with a more in-depth talk of experimental validity.